Okay, my name is Ashwani Yadav and I have done mtech from IIEST. Okay, so I'm going to solve illustration on electromagnetic induction. Magnetic induction. Okay, so we have rail and here I put resistance value R and one slider. This is slider of mass is M and resistance is R, and see, this is the parallel rail. This is parallel rail, and this is the connector of mass M and length is L, and magnetic field is inward. Now you apply a force F, and this is a constant. This is horizontal force, a constant force starts acting on the connector. Then you have to calculate the steady state velocity. Steady state velocity of the connector, and okay, now it is very easy one. If I give you only one resistance, now I make it little thoughtful and little conceptual by adding a capacitor here. Okay, one side capacitor, one side resistance. Then you have to be very enriched with good thoughts, with some concept to solve this problem. So I'm going to put a lot of good concept here. So I will pour it slowly and be careful. Okay, so now the calculate the state velocity of the connector and a steady charge. This is question A. Okay, a state charge on capacitor. This is your question 1. I will give you another question, but first solve it. Okay, no, I am just telling you the steady state velocity. This means it will take some time. So suppose the steady state velocity is V naught. Okay, this is your steady state velocity after time t. A steady state velocity after time t, and before the time t it must start with zero velocity to V naught, and meanwhile it must have function of time. Okay, but I am just talking you the condition when it has reached V naught. This is a steady state velocity, and at time t. Before this I am going to analyze in second section, right? So okay, one thing, a steady state velocity means constant velocity. Constant velocity, this means acceleration is 0, force is balanced on either side. Okay, this suggests term. Okay, acceleration is 0, that's why I am just telling you that this has some importance over this question. Okay, when it will get a steady state velocity v naught, in magnetic field and it has dimension length L, then we must have EMF developed over this between this length, that is v naught L length L. Okay, so now direction of EMF. Okay, what is the polarity, which one, suppose A and B, which one will be positive or negative? Motional EMF can be analyzed as cross product of vector B dot dl. Along that dl, if you get positive or negative, but we have done a lot of work upon it, so I'm just going to write this with positive sign. Okay, you can see it's a very easy one. It will take some second. Suppose coordinate system is x, y and z, so velocity v is in this direction, then it has I cross minus k and this is z. So now you know this I j k, so I cross k is minus z, and already this minus 1, z dot z, it is a positive quantity. So along this length, component of vector b velocity cross b is positive along this length. Okay, I am considering length along this direction y axis, so it has a positive polarity and this one has a negative polarity. So current will start coming from this direction. Okay, and here current is 0. Why? Because okay, let me describe this here, VB L naught. So along this length AB, okay, along this length AB, we will get VB naught L as EMF, and charge on capacitor. Charge on capacitor is nothing but CE, that is VBL and C. Okay, and this is not varying, so dq by dt current is I is equal to 0, because V naught is constant. If it is in acceleration, there must be a current along the capacitor, through the capacitor, sorry. Also, so current is 0 whenever the rod has a steady velocity. When it is in acceleration, then it must have a current through this capacitor. Okay, so what is the question? A steady state velocity. So this force, what is the magnetic force? Magnetic force must develop to counterbalance this force. This will develop in this direction. Okay, you can simply analyze by this vector operation. Just do this, you will find it is in this direction. I have done a lot of times. Okay, so I want to skip it now. So let's go forward. F magnetic force is ILB and current is nothing but E by R. So we have only this resistance is involved here, E by R, and E is equal to B naught L square, B square by R is F. ILB forces, ILB, I have put I as So we have calculated this one. So F into R by B square L square is V naught. This is your steady state velocity. Okay. Now the charge, a steady state charge is C EMF, that is equal to C V L. V naught is F R B square L square. This is your charge, and this has value C F R B L. This is your steady state charge over this capacitor. Okay. Now second section of the problems. Okay, just I am going to discuss about this Vt. What will the velocity as a function of time before reaching the steady state? So I want to develop this equation Vt, before developing the steady state velocity. So how it grows with the time. So I need to derive the basic equation. Okay, so my second question or second aim is to find the velocity with a function of time, and how it is growing to V naught. Just a mathematical function I want to develop. Okay. So when it is in acceleration, before reaching a steady state V naught, it must have acceleration. Okay, this means force will be unbalanced. After some time, this force ILB and this force will be balanced, and before that there must be acceleration because the net force in right direction. So before reaching that steady state, there must be a current passing through this capacitor. Okay, so let me write again in the similar pattern. What is the current through this one? EMF here. EMF is V naught V. Suppose it is velocity V at certain time, and L. So current will be like this. So now we have a current VBL by R plus current in this capacitor I have already solved. CBL V naught V differentiated with time, you will get acceleration. This is your current. Why I have find the current? Because I want to calculate the force, this force. Thereafter I will develop the Newton's from law of motion. Then I will develop the equation. I can find the V. Okay. Now from Newton's law of motion, F minus ILB magnetic force. This I, we have I. LB, and now we have I, VBL by R plus CBL into acceleration is equal to M dV by dt. Okay, I can here the acceleration, so I can write first. Let me simplify this expression. Then after I will develop the equation and solve it. So now F minus B square L square V by R plus L square B square C and A, and here you have a minus sign, that is equal to MA. Okay, I can simplify this equation we will get m plus l square b square c into acceleration. So now I have acceleration, and you can write acceleration as dv by dt. Whenever you find this equation dv by dt, this means it will give the function with respect to time if you solve this with integrand 0 to t. So let me do this very frequently. Fr, so let me write dv fr minus b square l square b, and this side dt r is going to be multiplied by this. So now r, this is r m plus l square b square c. So 0 with t and 0 with velocity, because you are starting with 0 velocity. Now this will give you the, so this solution will be, solution is your answer. Of course it will give the exponential one. So log fr minus b square l square b divided by minus b square l square, coefficient of this coefficient we will divide it whenever you integrate it. Okay, now we have time by r into m plus l square b square c. Now we have also integrated over 0 to b. Okay, just solve these equations. Okay, now माइनस इधर कर दो, ठीक है, माइनस इस साइड कर देते हैं. देन b square l square t by r into m plus l square square c is equal to fr minus, put velocity here v and 0, you will get fr. When you put 0 you will have only fr. यदि आप 0 यहाँ पुट करते हैं देन आपके पास सिर्फ fr ही बचा रहेगा. ये इक्वेशन है. आप ये देन लॉग को हटाने के लिए एक्सपोनेंशियल दे सकते हैं, एंड दिस इज माइनस साइन था यहाँ पे, तो लिख सकते हैं एफ आर माइनस बी स्क्वायर एल स्क्वायर भी बाई एफ आर इज इक्वल टू एक्सपोनेंशियल माइनस बी स्क्वायर एल स्क्वायर टी बाई आर m plus l square b square c. Now you have 1 minus this one, so f velocity I can write it directly by fl b square l square 1 minus e to the power minus b square l square t by r m plus l square b square c. This is your velocity with a function of time. Okay, so it's a very thoughtful one. When you have capacitor at one side and resistor on one side, then it will, after some time it will get a steady state, but before achieving the steady state velocity, velocity must vary with time. So this is your equation with the time. Okay, so I have put some enriched concept here with this problem, that when capacitor is added, if a steady state, it has no current. When it has acceleration, there will be a current. Okay, so this is going to be a very useful one. Okay, one problem from Irodov. So this is a ring. This is question from Irodov, and this is a ring, and O, and it has a slider connector, and which rotate on this ring, and it is OA. Length OA is R, radius of this ring, and this is conducting ring, and now we have one source of EMF. This is your source of EMF. Source of EMF is E, and its magnetic field is directed inward. Okay. Now it is kept in one thing. It is kept in vertical plane. Then mg force will act on it. Okay, this suggests us, okay, mg force will act on it. And circuit resistance is R. Circuit resistance is R. Okay, and here is a friction. Okay, here is a friction. It will rotate because gravity force will act towards the center, so it has a tendency to go downward. So force will act in tangential direction like this. This is a friction force. Friction force is also available here. Okay, so if rod rotates with constant angular velocity omega, then find EMF in terms of T. Okay, so EMF in terms of T. So it's a very thoughtful and concept rich, and it is rotating one. So this is a source of EMF, then another EMF. You have to find the direction of polarity, whether it is supporting that EMF, it will add. Whether it is against that EMF, then it will subtract. So you have to find the polarity, then balance the torque here. Okay, then you can find E. Okay, this is the basic fundamental things. You have to think like that. The pattern of thinking should be very much clear to reach the solution. Okay, one question is, one thing that it is rotating. Let me rub this. I have data. So one thing is that it is rotating under gravity, isn't it? So EMF will develop. So can you find direction of the EMF? Okay, so make it parallel. So this is I and this is Y or Z, and magnetic field is along K direction. So I can write EMF. Everybody know that EMF value is half B omega R square. This is the EMF produced in this rod, but I don't know which one is positive and which one is negative. How can I find this? Okay, just by making V cross B dot length, whether it is positive or not. If you get V cross B dot with length, positive quantity, then along the length you will get a positive polarity. So V cross B, whether it is velocity is going downward due to gravity, then velocity V is downward minus J cross minus K because it is inward. So J cross K I dot I, we will get positive quantity. So along the length A side has positive polarity and this is your negative polarity, but this has positive, but this EMF source of EMF against this EMF. So net EMF will be subtract this net EMF along AO is E minus half B omega square R. Sorry, V R omega R square. Net EMF, okay, because it is positive polarity, so it is getting positive and negative. Okay, so we have this one. So net current, now current, how much current will produce? That is nothing but E minus half B omega R square by R. This is the current. Now why I am finding the current? What is the root map of my thinking? If you are able to find the current, then it has a length. You know this quantity, remember, force is ILB. We have three things perpendicular to each other. Now we have a current, it has a length, a magnetic field is perpendicular to the length. So all three quantity are perpendicular to each other. Then I can write ILV. Force is ILV. So we have I current. Then you can find this force, and I can say by experience, because it will act at the middle point, but perpendicular to the length, because this is perpendicular to L and magnetic field. So this will be your magnetic force perpendicular to the length, and friction is also same direction, parallel to each other. Friction is F. Okay, no need to find in terms of mg, just F. Okay, consider F. Then right, okay, then you can it is okay. What is the question? It has a constant. You have to make it with constant angular velocity. Okay, you have to make it with constant angular velocity. Means constant angular velocity. What does this means? Constant omega alpha is equal to 0, net torque is 0. This is the equations. Balance this torque, you will get the answer. Now force cross R by 2 plus, because they are in same direction, friction R, this is the torque due to these two forces, and they are additive because they are in same direction. Now mg, so this is R sine theta r by 2 sine theta. Okay, with theta with time you can write this. So I can write mg r by 2 sine theta, where E is available. This E is available in this term f. So okay, let me rub this for a space. Now it will contain, force will contain this term ILB. Now I is E minus half B omega r square by resistance R LB. So here I have E. So now you can we have equation, and you can find now E by this equation. E minus half B omega r square by R LB plus F into R. Now from this equation you find E. Okay, now answer will be yours now. Very plus. Please one more step, and I'm very tired now writing, solving the basic one, so you can get EMF with time. Okay, because here we have a time. Okay, it is varying with the time. The source EMF will vary with the time. Okay. Now next problem, other very thoughtful problems. Okay, just you have to analyze the basics. Now you have a cone like this, and semi vertical angle is 45 degree. This is cone, and it hypothetical magnetic field is confined. Now consider hypothetical, this is another illustration. So hypothetical magnetic field, is confined in this cone like this. Okay, it is emerging magnetic field like this in this cone, confined in this cone. Outside there is no magnetic field, and now you have a conducting loop. Okay, like this conducting loop. Now you have conducting loop of radius r, is placed so that axis of loop coincide with axis of the cone. Axis of loop coincide with axis of cone. Now it is also moving with velocity v. Now find the EMF induced in planar loop when it is at a distance root 3r from point P. This is point P, and its distance is root 3r. Its distance is root 3r. Then you have to find induced EMF in the loop. Nothing but, same way, just take the elementary area like this, elementary area, okay. Then calculate the flux passing through this, integrate it, find the Faraday law, you can find the EMF. Just use the basic concept, basic use of your intelligence is enough to solve this problem. Okay, suppose this area is 2 pi y dy. Okay, like this is y and this thickness is dy. So ds is 2 pi y dy. Now the flux, this flux passing through that elementary area is vector b dot unit area dot ds. Okay. So let me make a clear picture of this. Okay, so here it is magnetic field like this, and this is your angle theta, and this is y, and this is your x, and this is x square plus y square. This is like this, and this is the direction of magnetic field. And area like this. So this is angle, though this will be also theta. So we have now B area 2 pi dy dot cos theta. Okay, so this angle between area vector and magnetic field. So we have elementary flux passing through that this finite area considered, a small area I have considered here. I will perform integration thereafter. So d phi, this is a basic thing in your mind. Now b 2 pi y dy cos theta, this is the p and this is the b. So we have x under root x square plus y square. So total flux is over perform this integration, we will get the total flux. Okay, now total flux is performing the integration. We have 2 pi x y dy, x is a constant, okay, x square plus y square 0 to r. This is your question. Okay, now let me rub this. Okay, I think it should be on mind. So perform this integration, you will get the flux, and you will get with r, and this is going to vary with time. So you, if differentiate it with time, you will get the EMF. So suppose x square plus y square is t square, then 2y dy is 2t dt. So this is part of your integration. Y dy t dt, and this is t, this is going to cancel. So this is very simple, t dt. Now its integration is t. So I will get under root t is x square plus y square. So now we have very simple b 2 pi x, put first of all put r, you will get x square plus r square minus x, then you put 0 to y. So this is your flux, and this is your function of x. So because x is this direction and this is varying with velocity, so x is nothing but vt, so function of time. So this is a function of time, so you can now differentiate it with time, and this will be your EMF, and then put x is root 3r, you will get the answer. Okay, I don't want to differentiate it. Okay, let me do this for you. Minus d phi by dt. Okay, it is very easy. You can, I want to skip it because integration, just do this, and then put x is equal to root 3r. Okay, thank you. I will I'm tired now, so next classes I will solve more problems. Thank you.